Welcome to the ninth section of this course. And this one is all about data, so additional data. We have our logic in there, we have our logic to play, to move around. This one, however, is about the little thing you collect in the game, those fishes, and also the score, and also saving. So the three big subsection you could call it of this section is one, collectibles, two, score, and three, the save file. And without further ado, let's just get right into it. The first one is going to be about collectibles. So this video is all about collectibles. In order to get some collectibles in this game, we're going to have to create some. So I invite you to actually lay down in the artwork, I believe there is a model for fish under gameplay. Here it is. So this model for fish, I'll actually anchor it at the center of the world. And actually look at the size. Is that a little bit too big for a fish? I believe so. The fish is actually bigger than the penguin. Not really cool. Just go ahead and make it as big as you wish, really. So I would believe that maybe half that size is good for me. And once I have the proper size, and it's right here, it exists, it's great. So the material for this one is some sort of black. Maybe I want to switch that to yellow. We'll see in the future. It's not a big change if we have to do so. And I will drag it inside of the prefab folder. We might also need another folder for this one, just called, I want to call it gameplay, but that's already taken. So just call it collectible. And drag and drop that in here. Okay, so we have our fish collectible, which is right here. In order for this to work, it's going to require a bit more. So here's what we will do. We will add a circle, not a circle, a sphere collider. The reason we use a sphere collider and not a mesh is simply in terms of performances. Sphere collider is the easiest one to calculate. Out of all collider in the whole engine, a sphere is simply your position and your radius, and it's a fairly easy test to make. So with that in mind, no, actually that's a good size. So I'll go ahead, override my prefab, and we're going to create a tag for this one. So I'll add a new tag under the fish and just call it fish. That should do it. Let's apply it to our fish, override, and apply. The next thing we'd like to do is actually take this collider right here and make sure it is on trigger. The reason we do this is so when our character runs into this, he doesn't get displaced and he doesn't has to move around it. It's not going to force our player to actually slide next to it and then go on a different path. It's not going to get out of the lane because this collider is going to be on trigger, which means you can freely walk through it without a problem, and the collision data will be sent anyway to this very specific object. Now, this object doesn't have anything that actually cares about having collision listened to, at least. So we're going to go ahead and make him care by creating a new component that we can just simply call fish. And I'll put that in my script folder for the moment. We can find him a place within the script folder, maybe by creating a new folder called gameplay. And now I'll just drag and drop that in here. Now our fish has a fish component, and we need to listen for different changes. And by change, I mean collision. So here is our mono behavior script. And I'll just wipe everything as I always do. And you can have a look at these following function. We have over here on collision enter. And it says that it's being called when this collider or rigid body has begun touching another one. So if there's a collision, this is going to be called on enter. So as soon as you enter collision, when you exit collision, you have another one for that. And while you are colliding, and every single frame while you're colliding, you have another one for that. Now, don't confuse the on collision enter with what we have to use in this case, since we're not really treating collision. However, we're treating a trigger. So we have other set of callback here. I wouldn't say callback. Let's just call them events in this case. We have another set called on trigger enter, on trigger exit, on trigger stay. They behave the exact same way. However, they are for trigger collider and not just normal collider that will block your way. If you see a difference in between 2D and the normal one, that's just because one of them is for the any type of collider that says 2D next to it. And of course, it's only being used in 2D. So private void on trigger enter, and here you get information about the other collider. That's why it's actually being called other. It's the other person colliding with you. So in this case, it would be the player. And we can check that by doing the following call. If other.tag is equal to player. Assuming that we have a tag, player tag on our player, I believe we do. We do not actually. we Let's go ahead and take our penguin and make sure he is tagged as player because that's our player and it's already built in. We don't even have to create that tag. Now, when that collision happens, let's call another function called pickupFish, which we'll just declare down here. So pickupFish. The reason I would like to create a function just for that is because I just want to separate things. And when we do pick up the fish, we could go and do a couple of things. We could play an animation. One thing for sure is that we have to increment. So increment the score or the fish count. We can increment the score, play a sound. We can, what else could we do? We could also trigger a animation. And that seems to be pretty much it right now. That's the only thing I have in mind. Okay, that's pretty good. At the moment, the only one we could immediately implement, I believe, since we don't have the score, we don't have the fish count, we don't have a audio machine, is really just the animation. So I'll go ahead and I'll implement very quickly a animation in here. So I'll do a private animator and I'll make sure to actually get this one in the start. So private void start anim is equal to get component. Oops. Get component type of animator. By doing this, I will grab a reference to my animator, and when I do pick up the fish, I can call a certain trigger, so set trigger, and just call it pickup. Okay, now it's going to be about creating a small animation with this fish that happens when you pick him up. So if we go in here, we can lay down a animator, and then if we open up our animation window, so that's the regular animation window, I can create a new animation called fish underscore idle, and then I'll do fish underscore pickup. And now we have two sets of animation for this one. I'll go ahead and I'll drag and drop these three inside of the prefab collectible right here. Now let's go ahead and do something with these. So we have the normal fish, which is right here. Maybe we can give it a slight animation where it moves a little bit. So what I'm going to do is anchor this down here so you can see a little bit better. I'm on fish idle. One thing that I realized might be a problem, actually will be a problem, is the fact that if we start animating this fish position, we're actually editing the world position and not the local position. Meaning that if we have fishes, say, around here in the map, and we tell it to animate on the world axis, which we are right now, they're just going to go back to the origin of the world and like start moving around here. Not the behavior we're looking for. So what I will be doing here is I'll actually go in my scene anywhere really and create a new game object. Make sure it is a top level object, empty, and I will call it the fish collectible, and I will drag and drop my fish beneath it. I actually don't need a prefab like this one anymore, but the fish collectible as one will be dragged back in here. So you see I've just created another prefab that is just, it's the exact same thing, but it has a top level with nothing on it, and then the fish is beneath. What I will do next is I'll actually grab my animator, click Alt. You can do that in Unity. I didn't know that for a while. Actually, I can't do that with this component. Okay, that's a shame. I will remove my animator, and I will head on the fish collectible and add it right here. Make sure I set it, and then I'll override apply all. By doing that, my logic stays on my fish model. Also, my visuals are still there. But now I can animate it in regard to the center of the world. So I'm going to go ahead and just move this fish back to where it should be in the center, and then take his parent, move it somewhere I can see, and we will start animating this. So as far as the idle goes, I'm going to go ahead and start recording. For the idle, oh, by the way, when you record, hit the record here, and any movement that you do from this point on will affect this animation. So be really careful what you move. But make sure, however, that you select the fish beneath. If you take the parent and you move him, you have the exact same problem that we've just discussed. However, if you take the fish, you can go ahead and just start playing around with the animation a tad bit. So maybe rotate 125 like so. And then after a couple of frames, you go back to not 0, I would say 90. Yep. And then a couple more frames. We could do 65, which gives us this sort of behavior right here, which isn't bad. And then to make a full loop, we'll go back to say 130, and I'll just put that back on the 120. And it will look something like that. So that's not too bad. However, as you can see, there's like a small hiccup at the end. We can address that in a second. But before I address this, I'm just going to go ahead and play with the y-axis. So I went at the y-axis, input 0. I'm going to go and say at the middle of animation, which is roughly at 45 seconds, maybe 0.2, and then back to 0 here at the end. So very, very standard animation that plays a little bit too fast in my opinion. If you want to make sure it plays slower, you can select everything, and then you have this blue rectangle here that you can drag out and say, hey, this animation instead of 1 minute, and well, actually 1 second and 1.5 second is actually going to be 3 seconds. And see, it's already much smoother. However, we can make it even more smooth by now going under the curves. And what isn't smooth in this animation is when it ends, so roughly around here. Oh, there it is. I had to zoom out quite a bit, but as you can see, what is messing up here is really those sharp, very, very sharp spike, which we definitely don't want. So we'll need to smooth them out, and they're right here. Yep, that's him. So he's a culprit right here. So let me check how I address this issue. Now, while you're navigating this, you have the middle mouse, which will help you zoom. But then if you hold control, you will zoom, but like just on the horizontal axis, which is what I have to do here to get the proper data that I need. So I might have played around with my animation wrong for some reason. It needs to do a really nice curve. So just go ahead and fix that manually if you have to. And for some reason, I think I have one over here. Yep. So that make a little bit more sense. I wasn't sure why this would happen, but it's fixed now. So 165 here. And if you're curious, your data is on the left-hand side, so over here where my cursor is. So I remember it being 125 for this one. And it doesn't matter if it's not exactly where it should be. It's an animation. It's supposed to be a little bit more organic. And then when you press spacebar and you play it, it looks much better. Okay, so I just wanted to make something very simple. I'm not going to spend the whole day on this, but that's it. Now, as far as the picking up goes, we can go ahead and record something very quick as well, which is going to be, say, for example, we can put it at 0.1 for the start in the y-axis, and I just want to make this disappear. So I'll modify the scale. It starts at 0.5 for me because that's scale decided, and then it's quickly going to go up, and very, very quickly. So I'm talking about maybe a third of a second, and then it will go up in the air at maybe 1 in y, and I'll just put the scale down to 0. So it completely disappears. So it looks like this, right? It's a very simple goes up and disappear logic. That can do it. Maybe it's a tad too fast. I would agree that it might be a little bit too fast. So And I don't feel like it's high enough, so maybe 2. That's a good start. We could go ahead and play with some particle as well, but that's going to be enough for the very simple animation we're looking for. Okay, so we don't have much things to play around with. As I've mentioned, we don't have the score, but at least we've input a animation in there, and I'm really eager to try it out. Hopefully we can do that, so I'll just take my fish collectible, hope there is no model in the way, and I'll hit play. You see what? There is no model in the way, so let me actually go ahead and collect them. Oh, I'm okay. I moved it a little bit outside of the lane, so let's try that again. Okay, now he's inside of the thing. Again. There we go. Okay, so it seems like I have an issue here. What could it be? For some reason, my is trigger is off, which is not the behavior I'd be looking for. So let's go ahead and add that. So is trigger is on. Make sure you add that while the game is not playing. And also realize that there is a problem. Missing component exception, there is no animator to the fish. And that's completely normal. That's because we moved the animator away. So it's no longer on here, but it's on the parent. So get component in parent would do the job here. Now with that in mind, let's hope we're lucky and get the proper prefab to spawn. All right, let's give this a try. And it says that pickup doesn't exist. Okay, so we forgot to do a couple more things. In the animator itself, we forgot to actually program the animator. So initially, the fish just goes idle. That's totally fine. And then at one point, any state will trigger fish pickup as long as trigger exists. So condition pickup. However, there's no condition. So let's head over to parameter. Add trigger. That's going to be pickup. And we can simply choose it from the list, which means this should now be triggered. If we're lucky enough to get the proper thing. Okay. And there you go. So that was it. It was really hard to see. Maybe I want to change its color. Once it is yellow, it might be a little bit easier to see, but we entered the picking up phase, which is good. Okay, so right now we have a good start. I'd like to keep this going on the next episode where we actually make sure to integrate this with the certain gameplay elements, so the gameplay chunks, and then also make sure that when we repeat those chunks in the future, these fishes are respawn because we reuse some of the same chunks. And if we reuse the same chunk twice, then chances are if we picked up the fishes in the first one, they won't show up in the second one. So we have to address this issue. Yeah, so we'll do that in the next one. Cheers. Welcome back to the collectible subsection of this section in which we talk about this small fish right here. We were discussing an issue at the end of the last episode in which if we are to put this on top of a gameplay prefab right now, this thing would disappear. If we collect it once and then we reuse the same prefab in the future, this thing might just as well disappear. So first, we will do that. We will show this problem happening and then we'll fix it. But of course, the reason why I'd like to show it is because we have to place these fishes somewhere at one point. So under gameplay chunk number 1, we could go ahead and actually place a fish prefab that we've created. So collectible, I could go ahead and place it somewhere roughly there. So maybe you would have to jump to get this one. And that's a fair place to put it. Now I'll go and I'll do the same thing in number 2. So I like to put that somewhere in number 2. For example, we could put it after the rock. So it would require you to actually jump. And that could be the place where you put this fish. Okay, now these two are being part of the game at this point. We just have to drag them in there and they should be part of the game. So you see one right here. Ah, there it is. So we have the fish right here already being collected. I don't know if you guys see it, but if I zoom in, this fish is really small. It's actually already collected, and for some reason it didn't play the animation all the way through. We can look into that right after. but that's not a complete fish. As you can see, it's way too small, and that's because I keep collecting them. This behavior is actually because, well, the animation was played, the fish collectible is there, and we reuse a chunk that was already used in the past. And that's where our problem actually comes from. So, oh, you see it now. It's actually being, he's actually spamming. There it is. That's a problem. It's actually spamming the animation in a loop. So we're going to resolve that as well right now. Um, so first issue is the pickup. Pickup, remove the loop time on it. That's the animation. So now it doesn't loop anymore. The second problem is that if we collect it, it's just going to disappear forever, not the behavior we'd like to have. Instead, every time that the chunk is being respawned, we'd like to reset this fish. And we can do so. We can do so with a bunch of different methods, but we'll explore something that I don't really do often, and it's the message, the sending message. Um, I would like you to actually check this out. So on this chunk right here, we have a script called chunk. We already have a point in which we know we're showing the chunk. So right here, right? So we know that when we do show chunk, it's technically just like respawning. It's like reinitializing that chunk. Well, what we could do is we could take this object, this game object, a chunk itself, so maybe this, and just on top of this, we can broadcast a message to everybody beneath it and say, hey, we're responding right now. You want to do something with this information? You're free to do so. If not, I don't mind. We can actually do that. And by making like broadcasting that message to everybody, our fish can say, hey, yeah, I do care about when you actually respond, and I'm going to respond as well. That's very much possible with the broadcast message, or I believe it's a send message. Is it broadcast? I believe it is broadcast. So under my chunk, that's yes. I'll go ahead and I'll do. So you have the option to do broadcast message. That is not recommended. It's going to broadcast to everybody in your scene, and that's way too expensive. So make sure you target this very specific game object. So I'll do transform game object, then I can broadcast a message to my children, basically. And that message is going to be the name of the method. So we can do on, or actually on show chunk, like so. Just writing it this way is going to cause problem because by default, this function does not allow you to just send a message without having a receiver. So you have to specify in case you have a chunk that doesn't have a fish, this might be a problem. Unless you write the following parameter. You have the send message option that can come up as a second parameter, and that's don't require a receiver. And by doing that, I'll now be allowed to have chunks that doesn't have any receiver on it. So check this out. Now we grab the on show chunk. We can head over to our fish and say the following. We will write down a public void on show chunk, and that will pretty much say, well, we have to respawn this fish. So we can set a trigger for idle. We can put the animation back on idle. That'd be great. And let's just put a capital I here because we put a capital P to pick up. Do we need to do anything else? I believe this is it. I don't feel like we need to do anything else. Yeah, so yeah, let's go ahead and do that. So let's go configure our animator right here. And just to make sure that I don't pick up this item twice during the same chunk, I'll add a couple more things to the animator. So let's go right here. I double click on the animator. I have idle, that's totally fine. Pickup is here. I'll add a new trigger for idle and link any state to that. Make sure also I have my proper condition in place. Okay, and I want to do one more thing just to make sure we don't pick this up twice. I'll open up the animation window, go on my fish collectible. How do I open the animation? I'll just drag this in the scene. Now I have access to the animation. I'd also like to record and make sure my fish sphere collider is active when I'm idle, and when I'm on pickup, it's no longer active. So we don't hit up the same thing twice in the same go. So that should do it. Okay, I am now ready to overwrite this, delete, and give it a try. And now we'll give this a try. So I'm gonna go ahead and go at the very beginning, see what is my first chunk, and it's this one, I believe. I can't click it because of the shader. Here it is. So that's the first one. World generation chunk 2 clone. That's the first one. I'll look at my fish. So here it is. And we will just keep on moving. So hopefully I can collect it first go. Yep. And it should be turned off really soon. So now, as you can see here in my scene view, it is being turned off. And I'll just have to wait until this one pops up again, which should be anytime soon now. And here it is, it's back. So as you guys can see, I have a fish and it doesn't seem to appear. So what could be the problem this time? The scale is on 0 and it seems like object was not set to the reference object, huh? Oh, and it turns out that I have a lot of no reference coming from this line because we spawned at the beginning. Okay, so that's right. We don't have the animator at this point. We can do a null check here. So on the animator, if you add the question mark, it's going to check if it's null first. And if it is, then it's not going to run the following code, so set trigger. What could be a problem here? It doesn't seem to go back to the proper state. And it says right here that fish idle is there. Oh, again, I get it. Okay, so the problem here is in the idle state, we never actually reset the size. So it's going to be on me to go back on my fish. And that's a mess up from last episode, so I'm really sorry about that. We have to make sure we set a size. So on fish idle, I'll make sure to put the scale of this fish beneath it. So this one on 0.5. It just didn't have a keyframe, so it assumed the rest of the information we've input, but it did not actually reset the size, which was a problem. So with that in mind, we can give it hopefully a final try. So I managed to collect the first one. That's my first chunk here on the right-hand side. It disappeared. We'll wait a little bit for when it responds. And it's back up. Okay, so I'm going to double click on it, see if I can see it in the scene view. And my fish is here, and it's whole. That's perfect. To make sure I can actually collect it again, I'm going to wait until my penguin runs into it. So where am I? I'm roughly around here. Okay, that shouldn't take that long. Hopefully I don't mess up. That'd be really awkward. And I believe here I am. And I collected it again. Okay, that's good. Amazing. So that logic is in there and it's working just fine. And that's where we're going to wrap up this episode. In the next one, we are going to be looking at saving the score and also incrementing the UI as well. So I will see you in the next one. In the last two videos, we made sure to implement the fish collectible. Now today we're going to be looking into implementing both the score and also one place where we get to keep all of that data. So one component, one C# class that would act as a container of all that data. So to do so, I will go ahead and right click on script and I'll lay down a new script that I'll call GameStat. And this one, just like a couple of other systems we have in our game, for example, the game manager in this case, we're going to do this very specific static instance here. So with that copied, I'm going to head back to my GameStat, open it up, copy it right here, and replace the game manager by the GameStat. Now we have a public static instance that we can access to from anywhere, really. And we're going to start laying down what we need in here. So two things we'll need for sure. One is the score, and then it's the amount of fish we have collected. And also we could do the amount of fish we have right now, so as a total. In fact, let's actually get everything in here. So I'll lay down a couple of fields here. For score, we will start with a public float score. Then we can go with a public float high score. Move on to the fishes, public int total fish. public int fish collected this round, this session, I'd like to call it actually. That's how we've been naming those play session actually thus far. And we could also keep in mind the amount of points we're going to give every time you collect a fish. So maybe public float points per fish when you do collect them. And then finally, we'll wrap up the field declaration section with a action. That action will be the following: public action on collect fish. So every time that we do collect a fish, we will trigger this action. Other people can subscribe to it if they wish. And every time it happens, then of course we send that call. This will be needed, for example, when we are on the UI for the game and then we collect the fish. Our UI will be subscribed to the game stat here. And as soon as we do collect that fish, then we get to know that it's time for us to change the text on the screen. In fact, we can now send it the amount of fish that we have during this session by actually adding parameter here for int. Now let's lay down the very first function we'll have in here, and that will be the public void collect fish. This will of course be called whenever we do collect the fish. And in there, one thing we'll have to make sure is that we actually call the event that we've made a second ago. It will be called with the fish collected this session because we're setting in a int as a parameter. So whomever is subscribed to onCollectFish will receive a message every time that we collect one, and also receive the amount of fish we have this very specific round. On top of invoking the event, actually before we invoke the event, let's actually increment the amount of fish we've collected this session, just like so. All right, now it's time to calculate the score we're going to have for this game, and it's going to be a very, very simple formula, and I'll actually do it in a update instead. So private void update. And here's what we're going to do. We're going to calculate the float score, or float s in this case, with two things. First, we're going to check where we are in the map on the z-axis, which means this is going to be the distance we travel since the start. And then we're going to accumulate the amount of fishes we have and then multiply it by points per fish. So our score is going to look something like this. Player transform. Actually, we need to find the player transform of the player, which I believe is on top of the game manager instance. Do we have access to the player? Yeah, we have access to the motor. .transform, .position, .z. And then we can multiply that with a score modifier based on the distance, maybe. So I did not add that here, but let's go ahead and do that. So distance modifier. For example, it could be 1.5. So every meter you make in the game, you receive 1.5 points. And then on top of that, we will add the score we're supposed to have with the fishes. So fish collected this session times points per fish. Now, if that score, if s is bigger or equal, I can always just do bigger. If it's bigger than score, then we're going to say score is not equal to s. And you would think that every single frame would be a higher score because we are further away in the distance z. But the truth is, we have a small thing when we die. We actually pull back a bit, and when that happens, our score would go down because we lose some distance. So the check over here is just to make sure that when we actually die, we keep the highest score where we have died, and not when we pull back with the animation. So yeah, that's why it's there. We're gonna put that back on 0 eventually. So no worries about that. Okay. And now one more thing that I just thought about, and you might be wondering why I'm thinking about this now. I do have notes when I make these videos. However, I like to improve on the code that I've made the last time at the same time. So something I didn't plan out is that we'll also need an action for the score itself. So on score change. And the reason is when my score change, my UI has to be subscribed to that event and also look for these changes so it knows when to actually update the text on the screen. Prior to that, if we have a look at my old code, I actually had reference to the text, and I didn't think that was cool. I didn't think that was encapsulated. So here's what I wanted to do instead. We're going to put that in action, and we will subscribe to it the exact same way as when we subscribe to onCollectFish. And that event would be called right in here. So when we're not playing, the score doesn't actually go up, and we are not calling this. It's a little bit more optimal. So on score change, and we're going to invoke with the actual score. Now you might be thinking, well, Michael, this is not optimal either. And you're right. The reason this is not optimal is because every single frame in the update, we're going to be firing that event, and that's going to be fast. So we're going to be updating the game. For example, if we do 60 frames a second, we are calling an event 60 frames per second, which is just way too insane. And on top of that, we do plan on having that event change UI, which means the whole canvas will be redrawn 60 times 60 times a second, which is way too much. It's going to be way too expensive. Now, it might work at 60 frames a second, and we won't see anything. We won't see any bump if we have a good device. But the matter of the fact is that it's still a very costly operation. So what we're going to do, on top of all of that, we are going to add a internal cooldown. And this will be done with two new fields. And I'll just add internal cooldown right here. Call it private float last update, actually last score update. And also on top of that, we can do the update delta. So score update delta. Say we want to update every 0.2 seconds, which means instead of doing 60 frames a second, actually, instead of calling the update 60 times a second, we'll be calling it 5 times, which is a lot more optimal, and it's going to look good. So with that in mind, we can now add some code in here and do the following. If time.time minus last score update is bigger than the update delta, then we're going to call onScore change, and we're also going to set the last score update to now. All right, so this is starting to look pretty good. We have the update, we have the collect fish. We're missing two type of function with this script. One, the high score, and the total fish. We need to find a way to report these, and also we need a way to reset these stats once we start a new session. So I'd actually let's do that right away. So public void reset session, which will have the following effect. So score is going to be equal to 0. Fish collected this round is also going to be equal to 0. And will we need anything else? I don't think so, but maybe we want to. No, we actually don't need to. Do we need to change these? I believe we might want to change these as well. So maybe onScore change is going to be invoked with score. And same thing for the other one, so on collect fish, which is kind of bad because now that I think about it, we're not collecting a fish here, so we don't want to do exactly what happens in here. But we're using this only to call the text right now. So maybe I would just need to revisit how I call this function, but that will do. So fish collected this session. And this is a big reset, which should happen every time we enter the game state. Maybe every time we enter the game state? Probably not, because we re-enter the game state at the same time as we revive. So when we revive with our penguin, we would reset the thing. So that's not a good place to do it. Where else could we do it? We can probably do it in a game state initialize. So let's head back into the game flow, I would believe. And in the state initialize, when we do onPlay click here, let's call it game stats dot instance dot reset session. Okay. All right, so we haven't seen this one just yet in action, and that's what we're gonna make sure it exists right now. So headed back on my game manager, I will add the game stat. And just to make sure, I'll just go and up this one. So move up right above all my states, like so. And let's have a look at it as we're playing the game. So we start right off the get-go with 0, 0, 15, actually not 15, but 1.5 for distance. And if we just hit play, we first have a problem with the null reference, but our score do go up and as I collect the fish, nothing happens right now. Don't worry, we'll be addressing that in a moment. But at the moment, GameStat.instance restart session didn't do anything. So that talks to me that we've never actually set the instance of GameStat. So right here, instance is null, which means we have to go back, lay down a private void awake, and make sure instance is equal to this. Okay, so small mistake here. Our second problem was that the fishes were not being accounted for. So as I collect a fish, if I don't miss, like here, we were not getting a total fish up and not getting a fish collected this session. Actually, we don't really care about total fish as of right now. We'll care about it once we end the game. But right now, we're going to head over to fish script. And when we pick up a fish, let's call the game stats instance collect fish. Okay. And as we're playing, we collect our first fish, and it's right here. So fish collected this round is there. We're at 2 right now. Points per fish was actually not set, so that was a problem as well. So maybe we want to set that to, for example, 10. It should be a bigger reward. So I'm going to make sure that on my game stat, this is being reflected by right-clicking, hitting reset. And then once we collect the fish at this point, of course, we should have plus 10. And okay, I just died. Okay, so our score did go up by 10, and that is great. That's exactly what we needed here. Next up, we need the UI to actually listen to this, and I think that's going to be the biggest part, the one that makes a lot of changes to our game. So to do so, we will head over to our game manager, find the game state game, open it up, and in the construct, I will now be subscribing to the change events. So how do we do that? We go like this: GameStat, instance, the name of our event, which I believe is right here. So on collect fish and also on score change. So on collect fish plus equal, and then we can lay down either a lambda expression, that could be cool, or just a new function itself. So to show you both, we're actually going to do both. For example, and feel free to use twice the same thing if you wish. But I'm going to do here one for collect fish, public, actually not public, private void collect fish, or on collect fish is a little bit more accurate in this case. It takes in a int for the amount of fish collected. And then we can write code down here. So all we have to do for this one is just paste in the name of our function, like so. But if you'd like to do a lambda expression, you can go and do the following. So on score change plus equal, open the bracket for parameters. In this case, the score parameter was, just call it S. Do a equal arrow, and then you have your function right here that you can call. So in this case, it would be score count dot text is equal to S toString, or just S. Actually, S is a float, so we have to do a toString. Okay, so you have the both option. Whichever you like is the best. That's really up to you. But at this point, that's the one I'll be using. I'll be using both, actually. So fish count dot text is going to be equal to the amount collected toString. All right, let's give this a try. And as you can see here, I have one fish and my score is going up. Now, is it going up in the manner that I'd like it to be? Not really. We might want to change that a little bit so it has a better display. But at least it's going up, and we can see a big change within our game. Now let's head into the code and clean this up a tiny bit. We have the construct over here. In the destruct, I'll make sure to unsubscribe from this event, which makes me realize that, by the way, I cannot do that because I can't I can't destruct it. I cannot unsubscribe this way. So it's going to be important that we actually adopt this method right here. I'm sorry about that. I just wanted to show you something more. But yeah, I'll actually take what I've made over here and I'll paste it down there and just add the unscore change. Reason being, as I've just mentioned, is that we're having issues unsubscribing for these, which is going to be important because we do that in a construct. So every time that we re-enter this, we would be subscribing the same function to the same event, and that's not cool. Unless, of course, you do minus equal on these once you're done with them. So one more thing we'll do to wrap up this video is to make sure that my two strings over here, they look actually a little bit better than they do right now. We could go ahead and for example, for the score, we could say toString, but you need to have a minimum amount of digits in here. And to do so, we can put it in quotes. Say we want to have 6 zeros. We can do it this way, and it's going to make sure to actually format our string in such a way that if we have 25 of a score, it's going to write it this way. So let's give this a try so you can see what I'm talking about. And here you go. So it actually makes sure to input a couple of zeros at first. And I'd like to do that also for this one here. So 3 zeros. And if we want to go even better than that, we could go back on the game stats, create two new public string score to text, and public string fish to text, and return the following. So score toString 6 zeros, or actually 7 in this case. Felt like there was one missing from the space. And same thing for the amount of fish collected this session. By doing this, it will leave me one place where I can just change the amount of zeros, and it's going to be reflected everywhere in my game when I use it. Now going back on the game state here, I can just say game stats dot instance dot which one was that? Fish to text. And here, score to text. Okay. And I think we're pretty much done for this one, yeah. We've been talking for a while. We can then go back after this and clean up our little mess for the next episode. But at the moment, I think we have enough, and we can then move on to the third part, which will be saving. So I'll see you guys there. Welcome back to the last subsection of this section, which is all going to be about saving and saving your data. For this one, we will be creating two scripts, and they will be stored inside a new folder called save. What we're going to be doing is we're going to have an object that controls saving and loading data, and we'll have another object that is just a data structure, and that data structure will explain what are we going to save, exactly what it's going to be. So that being said, we are going to start with the data structure. I like to call it the save state. So everything in here in this class, and it's going to be a fairly small one, will be things that we will save. So I just want to make sure that you understand that everything put inside of here will be saved unless we tell it that it won't, which we will also do by the end of the tutorial. This one will not inherit from model behavior for the sole purpose that it's not an object that we'll just put on another object. It's just going to be it's a real data structure or data class in this one. And one thing that will be really important with this data class is that it is a system.serializable class. Now, when we do that, when we actually lay down a class that is marked as serializable, we try to only use things, and when I say things, I mean types that are serializable. So pretty much all the basic types are, so int, float, byte, date, time, the really simple one are really all serializable. And if they're not, if you're trying to add your own custom type into there, then you can overload something to make sure it is serializable. But for us, really, we don't need to keep anything too complex. The thing we'll need to keep are the following: a public int high score, And I marked these as property. That's why I have a capital here. A public int fish. That's going to be a total amount of fish, by the way. And you know what? At the moment, that is all we need. Eventually, we'll need a little bit more. And just for show purpose, let's also add a date time. Why not? For the last save time, in case you want to put your save on the cloud, it's something you actually need to compare whether or not which one is the latest save. But I do not plan on making this to the cloud at the moment. But eventually, there's nothing stopping us from doing so. And there's a couple of tutorial on the YouTube channel that shows you how. It uses the same principle as a save state, so that's even better. Okay, let's say that's all we need right now. When I create my game, I would like to have the default save state in case we're not able to load any of those. So in case we don't have a saved play session prior, it's the first time we open the app. Let's create a default one. So public save state, and that will be the constructor. And here we'll just say, hey, you know what? Fish is equal to 0. We're starting off fresh, and also high score is equal to 0. And the last time we save is actually right now. So last save time is going to be equal to datetime.now. And that's it. That's all we need in this class. Actually, you know what? Don't even need Unity Engine using Unity.engine. That's all we need in this class right now. We're saving only 3 values: high score, fish, and of course, when is the last time that we've saved. All types are serializable, including datetime. And yeah, we're now ready to move to the save manager. Now, just like all the other managers we have in the game thus far, we will create a public static instance for those. So if we have a look at the game manager, I'll just copy over this code and make sure I actually paste it inside of the save manager. Of course, change the name of the class, and then we now have a public static instance. Okay, couple of fields that we will need for this one is one, how should we name our save state? So private const. I'm gonna make this one const because we're never gonna be, we're never actually gonna change that unless you go directly into code. How do we call our save file? Save file name. We could call it something like data dot subway skater save file. You can invent whatever format you'd like to have, actually. SS sounds good. So save state or save or subway skater, that also works. Okay, so now from this point on, the goal of this class will be the following. Once the game starts, we will have to grab a file within our game folder, grab a file called data.cc, or SS actually, and we will have to deserialize it and then input it inside of our game. If there is no data, we create one. And also, every time that we call a certain function we'll create in here called save, we take our save state, we serialize it, and then we put it back to that file. So we will start with the easiest part. Private void awake. We're going to be looking for a file. Our goal of looking for a file will be to try and load the previous save state. Then what else will we need? That's it. That's actually all we have to do in the awake. Yeah. So we will call the load function, which doesn't exist right now. So we'll create it. So a private void load. And now what should we do in here? For our load, it is now time to pull on the gracious system.io to actually access file on our system. And we can do so like this with a new file stream. Now I don't have that access thus far, so I just hit Control and then dot on the keyboard using system.io. So in case if you missed it, it's right here. A new file stream, and then we send in the path, I believe. So not this one, yeah, the path. So that's our save file name, followed by the file mode. So file mode dot open in this case. And then file access, we would like only to be able to read. So we're opening the file and we're just trying to read it. This returns us a file stream. So we can go here, file stream, call it file, and make it equal to that. Okay, now chances are this might fail. This might fail for the whole reason that there's a chance that there is no file called data.ss in this folder. And if that's the case, then I'd like to actually just be able to wrap this up in a try catch. So this is what I'll do. I'll wrap this logic in a try catch, and if it doesn't work, then I'll just say something like debug.log save file not found. Let's create a new one. And then call the save function that we don't have at the moment. We'll get to there in a second, so don't worry about this one just yet. Okay, so going back here, if we found a file, then let's actually assign our save state to it. Now, do note that we have actually never referenced our save state, so that's my bad here. We should have that as a field at the top. So public save state, and I'll just call it save. I don't need to be, it doesn't have to be more complex than that. It's just a public object that contains all the data for this very specific application, actually. It contains everything for the whole application. If we found something, let's say save is going to be equal to save state, we'll have to cast it because now we are trying to deserialize a file stream. Okay. Now, that might be a little bit complex at first sight, but just think about this. We have a file on our file system called data.ss. This is most likely a text file. It has string in it, right? A whole bunch of character in there. We are trying to make sure that this string, or very, very long string, is actually equal to our own save format. And we can achieve this with a deserialize. However, at this point, we've never actually decided which type of serialization we're going to go through. There's a couple of different ones. You have a binary formatter. You can format in memory. You can format in a bunch of different ways. One that I like quite a lot is the binary formatter. Now you're free to use whichever one you like. It doesn't really matter if you know how to serialize, deserialize, then do whichever you like. But I'm going to show you how to use the binary one. And to do so, I'll actually declare an instance here at the top. So a private binary formatter will need to include the following here. So runtime serialization formatter binary, and I'll just call it formatter. For this one, we actually need to instantiate it at the beginning, not instantiate, but create a new instance of that class. So at the top in the awake, I'll say formatter is equal to a new binary formatter, just like this. Okay. Now with that in mind, we can go here, remove the comment, and say the following. I want you to, and I'll just remove this, make this a little bit more clear at the beginning. I want you to deserialize the object I will receive in the file stream. So formatter dot deserialize, and then the stream itself. Now, as I've mentioned, this is going to return you a object, so you need to cast it, in our case, as a save state. Or you could just write it at the beginning here, like I've done earlier. Both are the same thing. Once you're done, you can actually go and close your file stream. So file to close, and you're pretty much done. So you've got it. Maybe we would like to add an event to make sure that we know when things are loaded. So just to do things in a good manner, we can go here and create two new action, public action, and then say save state on load. Same thing here, so on save. We will need to do using systems, and then we can call onload invoke with the save state. All right, so that is in case we found something. So if we found a file, then we're going to load it up and then replace the public save state save for the new data. Now, in case we didn't find anything, well, I would like to create that file actually. So we have our private void load, but now we also need to have our private void save. Or you know what? This one should actually be actually they should both be public so we can call it from outside sources. Yeah, let's do public void save and also public void load. Not that I think I'll be calling it. Not that I think that we'll need to load anytime soon, but saving for sure, we'll need to call it from outside a couple of times. So once we finish a game, we need to save pretty much every time because we might have a new total amount of new fishes. And right in here, we will start with a check. Are we being sent here because we go through the load and we don't have anything to save? Or are we being sent here through a override? So let's check. There is no previous state found. Create a new one. And we can do so by checking if state, oh sorry, not state, but save is equal to null. Then we're going to create one with our default constructor. So the one that sets our default value. So fish is equal to 0, high score is equal to 0, and last save time is equal to now. Which is a bit weird because we're going to override right here. So set the time at which we've tried saving. And we can say save.last save time is equal to datetime.now. And then we're going to open the bridge in between the game and our file system. So just like we've done earlier, we're going to take this line of code and I'll just paste it here. So open a file on our system and write to it. We're going to need a couple of different access in here. So instead of doing open, we will do open or create. And instead of writing, we will need a full-on write access. Now we can actually write to this very specific file stream using the formatter. So formatter.serialize. We want to serialize this file stream, the one we just created, and then the object will be our save state. Once we're done, we can close the file stream. And finally, as a good measure, we can then call unsave invoke with our file state. Okay, that's a lot of code and we haven't really tried it out. So I'm hoping everything's gonna work on the first go. I don't see why it wouldn't, but let's give this a try. To help you out, you can open up your folder over here. So I'm on my desktop and that's my project folder. Here you can find all the assets. Go back one step. So on your top level of the folder, you can now well, first, you will have to drop the save state on top of something. So here, for example, on top of the game manager, of course. And then hit play. And it says save file not found. Let's create a new one. Okay, fair enough. Let's have a look. It created data.ss. If I am to open this up, for example, with Visual Studio Code, it says the file is not displayed in the editor because it's either binary or used unsupported. Okay. Well, let's use another text editor. So Sublime usually doesn't really care about these type of stuff. So let's see. And here we go. So that is our save state in binary. And now here you'll be able to find data about your save file. Now do note that it's not just binary. It also includes the name of the class. So for example, save state. It has a couple more information than just the the 3 field that we have in there. That's why it looks a lot more complex than it should be, but that's because it's actually carrying more info, such as the name of the classes. And now we have that. Let's go back in our game. I'm going to clear the console, see if on the second time it can open it up. And it seems like it has, so it should actually be loading up. I don't think we'll be able to see it, but yeah, we're not able to see it, but it should have loaded up our previous save. Hey, Michael from the future here. I'd like to bring a correction to the save manager. I've just tried this on my Android device and it didn't work properly because we were not saving the save file at the proper place. Now this works. This works wonder on PC in the editor as well. But once we enter the Android device, we'll need to specify something more in the save path. So here, for the file stream, when I create it, I also want to add the persistent data path first and then my save file name. I'll need to do that in both the load and also the save over here. So make sure you bring that change here, or else this is not going to work on your mobile devices. All right, so I hope you join me in the next episode in which we're going to be testing it out and also hooking our all of our text and in our high score on that. We will be hooking up the save to when we finish the game, when we need to save again, when we spend money, if we ever do, in the shop later on. We'll be hooking all of that up, and we'll be testing it out in the next episode a little bit more thoroughly. So see you there. Welcome back to the final video in this section that is the data section, in which we save the data that we need for our game to persist over multiple uses. That being said, last time we left off, we had a save state, though we couldn't really see it, but we have a save state flying somewhere, and it keeps track of my score and also the amount of fishes that we have in this very specific game. However, this is not connected anywhere. We actually never overwrite the high score. We never actually write any of that data really to the save file unless when we start the game. So that is not really something we'd like to have in the future. So just to make sure that we have something that works and it makes sense, today we're going to be hooking this up to our game. And the first place that we could actually start this off is by saving when we actually end the game. And we will need to save pretty much every time we end the game for the sole purpose that we might have collected some fish and we'd like to add them to our bank. That being said, when do we save exactly? We save at a very specific moment we click on this one button here. And that's pretty much when we click on the button to start over again in the game state def. So to menu right here, that's where everything happens. And let's see, so scene, no, nope, nope. And let's see, have we ever hooked the reset? So our saving logic should be happening right here in the game state def. When we accept our def, when we don't hit resume game, it should be happening right here. Down there, all we have to do is the following. Game stats. Actually, sorry, no, that was the save manager. So save manager instance, and then we just call save. And I just realized I put a small, oh wait, no, save with a capital S. There we go. And now with this call, we should be able to save every time that we die. I believe at the moment, since we're not buying anything, I believe that's the only place where we actually need to save. I think I'm okay saying that. I don't think I'm wrong. Okay, but later on, for example, when we're in the shop and we decide to buy an object for a certain amount of fishes, then we will also need to save right off the get-go. Now, one thing that comes to mind at this moment is that we actually never set the data inside of there, however. So we never say, hey, score is equal to this, or high score is equal to this. And that's something we'll have to do when we decide to go back to the menu here as well. So prior to saving, set the high score if needed. And for this one, that will be fairly simple. We'll just compare the two int, and whichever one is the biggest one, then that one will win. Let's go through the save manager. Instance save dot high score. If this one is bigger, actually is smaller than the current score here being a, I believe that's a string because that's not the right thing here. Then the game stats instance score. If that's the case, then we're going to go ahead and say that the save manager instance save, that's the state, high score is going to be equal to the game stat. Just like so. Here you'll find out that the high score is actually int. We decided to save it as an int and not a float value because I just want to keep something here a little bit more clean. However, when we do run the game, we are not upping a int simply because the distance of our player is a float. However, we can come here and just make sure we cast it as an int. So that's possible. And also make sure to do it on the if call as well. All right, so that would be it right here for the high score. We can now go and do the second part of this, which had to do with the amount of fishes we collect. So if we head back to the save, and then we get the amount of fish we have, we can do plus equal the amount of fish we have this session. So game stat instance points per fish, I believe. And I think that's all we need here. What the problem is, it's so fish here is that, and oh wait, that's not the points per fish I was looking for. It's the amount of fish I've collected this session. So fish collected this session. And for this one, we don't need to do a call. We always increment. And if we have to increment by 0, then I mean, we're not really changing at this point. Now I want to head into our game and see if this actually works. So if I am to press play and leave the game running, just collect a bit of fish and also make sure I have a high score. And then I need to actually die here for the sole purpose that our save is being called when I press on this button. So I'm going to click on it and it says no reference exception. So that is going to be a problem. It seems like our save manager doesn't have a wake, so it doesn't have an instance. And we forgot about that in the last episode. Again, my bad. We have to make sure we have an instance over here. Usually when I do create some sort of singleton like this, I use another class that I can just inherit from, and it does that all for me. I just didn't want to add this complexity in the course. So that being said, let's give this another try. And let's actually play this. So I have my first fish. And there we go. So I have a total of 2 fish. I'm going to make sure to die and click on the button, this one. And now we're back at the beginning. What I'll be doing when I enter this scene right now is to display the amount I have directly here on the game state initialize text. So if we are to open the game state initialize, instead of saying high score text, I'll do the following. Save manager instance save high score, and we'll do a toString, just like we did for the other one. We'll do 1, 2, 3, 4, 5, 6, set 7 zeros, and same thing for the amount of fishes. So, oh, we could also leave the text in the front. I forgot about this one. So that means maybe I don't want to have the zeros actually. Yeah, so high score, and here we'll do fish plus save manager instance save the amount of fish we have. Okay. And if our whole loop works, right now, I should have a total of 2 fish, I believe. I have a total of 2 fish and a high score of 101. Let's give it a try again. So I died. Technically, I should have 3 fish. And I have only 2 right now. It leads me to wonder maybe it's just a timing issue. So I'll just run into the wall right now, see if it's now on 3. And it's now on 3. So I guess that's a timing issue. We can go back to our gain state def. And before I change my brain here, maybe I want to run all of this code prior to it. Yeah, that's going to make a little bit more sense. So everything save related will be done immediately before I go back to my game state initialize. I'll give this one more try. We have 3 fish right now according to the game, and I'm just going to die. Press this button, and I now have a total of 4. So it seems to work perfectly fine at this point. Okay, one last thing just to make sure everything works is I'm going to make sure I can override the 101, which was my high score at that point. Okay. So 130 should be my new high score. 131, here it is. All right, so we got pretty much everything we needed in terms of these texts. One last thing we need to hook up before we leave is the following, the def screen. It's pretty much the same exact thing. So let's head back to our game state def. So game state def, this one actually. And I just realized right here that we have a high score text that we might want to override in the construct of the def state, and not so much here. So I'll actually move only this section, or maybe I should move both sections. Yeah, I'm actually going to move both section of this. Sorry about being so moving this around so much. But I'm actually going to set these and save every time that I actually die. So if we revive, it's still going to be there. I took my code and I'm going to input it right here. So prior to saving, we set the high score. That's totally fine. Then we set that. Yeah, the amount of fish is also good. And we can then modify this high score based on what we had just done over here. So we can say high score is going to be save state. Sorry, wait, save manager instance save high score. And then the current score text can only be game state, game stats instance score, which we can also do to string, actually score to string or score to text actually. Fish total will be save manager instance save fishes total fish. And the current fish will be stored in fish to text, like so. Okay, I believe that's all we're gonna need. Yep. Something we can also do right here, if we do reach a new high score, we might want to change the color of this font maybe. So the high score.text. Let's actually take that and say color is equal to color.green, for example. Else, just put it back on color.white. Okay, yeah, that should do it. So I'm going to go ahead and just make sure I run into the wall. Total fish 7, high score 131. That's my current score. That makes sense. Yep, everything makes sense. Now I'm going to play again and make sure I beat my score so I can look at my new green color. It's most likely a really awful color, but we'll give it a try. I believe it was 131, so I should be beating it right now. And let's run to the wall. Text should be green. Oh, I took the wrong text, but yeah, that's exactly the behavior I'd like to have, but just on this text down here in the current text. So I'll just change the current score and we'll be good to go. Okay, I think that's it. I think we've done pretty much everything we needed in terms of hooking up the data. Hey guys, Michael from the future once more. As we start playing around with the save state, and as we start setting stuff in the construct of multiple of our state, for example, in this episode, we did stuff in the game state game, I believe, we might encounter one problem that the code looks like this in your end, where this is being called, and the construct of states are being called prior to the save state loading. So it's going to be very important for us to, under the save manager, put this in a private void awake. So this is ran first, and then under the game manager, when we create our state, put that under a start. So it is being run second. This is how we're going to maintain the order of what runs first. So the state should be, the save state should be running first, should be created, should be loaded, and then everything that has to do with these are next. So in the next section, we are going to do a little bit of polishing of the game. So we're going to pimp it up a little bit, make sure that our shadow looks nice, make sure everything looks nice, because right after that, we're going to be entering something that is a little bit more optional for the game. So we have a game flow that works well, but we want to go one step further after that and create a shop, and also make sure we have ads in our game so we can generate a little bit of profit for ourselves. So that being said, congratulations for making that far. You now have a game that has a complete flow to it. You can actually publish it if you wish right now, but I do encourage that you add a little bit more value to it, add your own flavor, and we're not done. So stick around for the shop in the next section, and stick around for the next section to make a little bit of profit off this game when people play it. Okay,